Hi Leetcoders, I hope you're having fun. And Saturday 7/11/2020 is treating you well. Let's try to do this problem 1480, running sum of 1D array. And you are watching Harper Data channel. So this problem is very fairly easy. It's kind of good for interviewers to see if the guy they are hiring is not a complete bojo. So after they have asked you a bunch of behavioral questions, bunch of hey, what do you think about this company, or do you have any questions, domain knowledge, and they have 15 minutes remaining, and they want to see if you can do some amount of coding. They might ask you this question to just see how you think and what is your logical way of thinking. So it says basically it's running sum of a 1D array. Given an array nums, we define a running sum of an array as running sum I equal to sum nums I, nums 0 to nums I, which is fairly self-explanatory, I would say. Now, so the example he gives is 1, 2, 3, 4, and this is 1, 3, 6, 10, because the first number is there's only itself, and so and then the next you add the previous, so 3, and then you add 3 plus 3 6, and then you add 4 10. So that's fairly easy. Same thing here, as you're building, he actually even tells you how the running sum is of 10, and then the same thing is true here. So it's kind of self-explanatory. I wouldn't waste too much time on examples. So in the coding interview, you just start basically think about how to get it. So you know that you have to return an array. So that means we need an output list or array, and with that we should also be able to walk the input, and that is done in Python as range with the range operator. So you say so here we are len. Now this range, when you say range n, it goes up to 0 to n minus 1. So basically you will get to iterate over n elements when they would be indexed from 0 to n minus 1, and that's the effect of walking the whole input array. And then you might think that all we need to do is result I equal to basically the sum of the previous element, right, plus nums I. But there is a catch, because I could be 0. When I is 0, the first element, the result I minus 1 will be negative, and we would run into problems. So we can fix that by saying if I not equal to 0, then we are good. So that takes care of the fact that we do not want to index negatively. So here that takes care of that, and then we can say else. It's very easy because we have only one element so far, and that's just nums I. Now you would think that this should actually work, but it will not, and I will let you know very soon why. Because what would happen is, let's see, it says if I not, okay, that one was easy to fix. Now it's saying list assignment index out of range, and that's because I think we are assuming, or coming from my C background, it's the classic mistake I'm making is assuming that the memory for the ith element of the result is already there. It's like I'm indexing into a pre-allocated array, but the fact is that there is no array. We have to basically build it as we go. This is a dynamically, the Python will do it for us. So basically the way to go is you don't say result I, you say result dot append, and that's how you build a particular element here. And the Python in the background will do the job of malloc and things like that. You don't have to worry about that. And the same thing happens here, result dot append. So the ith element is built. The logic is the same, but you could just say this is just a syntax thing, a little bit conceptual thing, in the sense that you're kind of building this on the fly. So now let's do this, and there you go. So it's accepted, it's looking cool. Now let's try to do a submit and see if that passes as well, and if that does, we are good to go. So there you go. So it's basically 84 millisecond faster than 7.35% of Python assumption. That's cool. Awesome. It basically works. What is the runtime complexity here? The runtime complexity is we're just walking it once. So it's ON. And there's no, I would say the space complexity is also ON, because you are allocating as many elements for the output array as you have the elements in the input array. So ON both for time and space complexity, and hopefully the interviewer would basically want to know that, and you can answer that. That's pretty easy, and you get to a little bit do some kind of coding and show that look, I am not a complete bozo and I can actually code and I can actually think logically. And with that, I would leave you guys doing your exercises for your interviews, but otherwise I wish you all the best in your interview journey, and hope you have been enjoying the Harper Dada channel, and I will see you guys in the next video. Until then, goodbye.